Hello, Mandela class. Welcome to your fourth maths lesson of this week. Thank you to those of you who shared with me what you struggled with during the previous lesson. So one of the pieces of one feedback that I got was that you struggled a little bit with activity 2. So I've just copied and pasted one of the examples from activity 2. We'll go over it quickly before we start today's lesson. So in the previous lesson, we looked at working systematically to find all the combinations, all the possible combinations that we could make from two groups of items or things. So here it says, the cafe sells the following sandwiches: ham, tuna, cheese, and chicken. The cafe also sells these drinks: orange juice, tea, coffee, and water. How many different combinations can you make? And how many of these contain tuna sandwiches? Well, let's take it one step at a time. We're going to answer the first question first and then move on to the second question. So we wanted to work systematically so that we don't get confused with which combinations we've already made. So I'm going to start matching the ham sandwich to all the drinks, and then moving on to the tuna sandwich, then the cheese, and then the chicken. So I'm going to start with ham. So I'm going to write ham, and one possible drink that they could have is orange juice. Ham and orange juice. They could also have a ham sandwich and tea. And tea. They could then have ham sandwich with coffee. So I'm keeping all the hams the same until I've matched them to all the drinks. And then they could also have ham sandwich with water. Okay, so here we've made all the possible meal combinations, meal and drink combinations using the ham sandwich. So I can now move on to a different sandwich. I can move on to the tuna sandwich. I'm going to cross out ham so I don't get confused. I've matched ham with all the drinks. Now tuna. I could have tuna and orange juice. I could have tuna and tea. So tuna and tea. I could also have tuna and coffee. And lastly, I could have tuna and water. So I've also listed all the possible combinations that I could make with a tuna sandwich. I'm going to cross out tuna. Okay, so now I can move on to making combinations with the cheese sandwich. So cheese and orange juice. Cheese and tea. Cheese and tea. I could also have cheese and coffee, or cheese sandwich and coffee. And finally, I could have a cheese sandwich and water. I've kept all the cheese sandwiches the same so I don't get confused. And lastly, let me cross out cheese. We have got one sandwich left, which is the chicken sandwich. So I'm going to start listing my possible combinations with the chicken sandwich. I could have chicken and orange juice. I could have chicken and tea. I could have chicken and coffee. And I could also have chicken and water. Okay, So now I've listed, I don't have any more sandwiches to match with any of the drinks. So I've listed all the possible combinations. I had 1, 2, 3, 4 sandwiches and 1, 2, 3, 4 possible drinks that I could have them with. And I've listed all the possibilities here. So how many different combinations can you make? Let's count them together. 2, 4, 6, 8, 10, 12, 14, 16. I could make 16 different combinations. How many of these contain, so I've answered this question, 16. How many of these contain tuna sandwiches? Well, all I need to do is have a look at which juices I've matched with the tuna sandwich, or the possible combinations. These are all the possible combinations with a tuna sandwich, and I've got 1, 2, 3, 4. So how many of these contain tuna sandwiches? 4 of them contain tuna sandwiches. Now you would answer these using full sentences, but it's a bit difficult for me to write with this pen. Okay, let's move on to today's lesson. Again, some of you've already given me feedback as to how we could possibly do this. So you've had a go at activity 3 from the previous lesson. Well done. If you didn't, don't worry, we're going to cover it today. So your learning objective is, can I calculate the possible combinations resulting from two groups of objects without listing them? What we've done here is we've listed all the possible combinations. We want to think about, is there any other way we could do this without having to list every single possible combination? Okay. Let's just quickly recap. So how many different possibilities are there here? The astronaut picks 1 red card and 1 black card. So how many combinations are there altogether? So you can pause the video and have a go at doing this yourself. You don't need to draw the shapes. You can see that the red cards have got different numbers, and the black cards also have different numbers. So all you really need is 2 different colored pens or pencils. Okay, so how could we do this? Well, we want to list all the possibilities, and we know that the astronaut picks 1 red card and 1 black card. So I'm going to start with the number 4 in the red card. I'm going to match 4 and 6 from the black card. I'm going to keep the 4 the same. 4 and 7 this time. Then I'm going to match 4 again to 8. I've matched my number 4 in the red card to different black cards. Okay, now I can move on to number 5. I've got 5 red that I'm going to keep the same. I'm going to match it with 6, then match it with 7, then match it with 8. Now I can move on to the 6. I can match 6 red to the black one, to 7, and match 6 to 8. Finally, I can match my 7. I'm going to keep the 7 the same, match it with 6. Again, keep the 7 the same, match it with 7. And keep the 7 the same. And finally, match it with 8. I've made all my possible combinations. Now, the second part, or let's count in 2s to see how many possible combinations we've made. Well, this is one combination. This is another combination. So we'll just count it one by one because it might get confusing with the cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there were 12 possibilities. How many combinations contain the black 8 card? So we need to look at where we've used a black card with a number 8. I can see one here, 1. I can see another one here, 2. and another one here 3, and another one here 4. 4 of those combinations include a black 8 card. Now, yesterday, as previously recapped in the last slide, we looked at working systematically. Is there another way we could have found all these possible combinations? So, how many red cards do we have? 1, 2, 3, 4. How many black cards do we have? 1, 2, 3. We've already figured out that we can make 12 possible combinations. So we've got 4 red cards and 3 black cards. We made 12 combinations. Can you find the total number of combinations using these two numbers without listing them? Pause the video and have a think. Do you see any links between the number 4, the number 3, and the number 12? Okay, some of you may have thought, where have I seen the number 3, the number 4, the number 3, and the number 12 in the same number sentence? If you're confident with your multiplication number sentences, you may have noticed that 4 multiplied by 3 equals 12. So that is another way, a quicker, more efficient way of finding all the possible combinations that we can find from 2 different groups. So we've got one red group, which contains 4 cards, and then we've got one black group, which contains 3 cards. So 4 times 3 equals 12. We already know that it's 12. We know that the answer is correct because here we've already made all the combinations and we figured out that there are 12 different ways we can match them. So this is a more efficient way that we could find out all the different possibilities. Ava chooses a snack and a drink. What could she have chosen? So she's got this many snacks and she's got this many drinks. We've got 2 different groups. How many different possibilities are there? I want you to calculate this without listing them. So using the method in the previous slide. Pause the video and write that down on your scrap piece of paper and play the video when you're ready. Okay, let's see how many snack options she has. 1, 2, 3, 4, 5. She has got 5 snack options and she has got 3 drink options. So this would be your number sentence. Well done if you got this. If you didn't, you can write it down and pause the video and have a go at calculating what 5 times 3 is. Okay, I know my 3 times table and I know my 5 times table. So I know 5 times 3 equals 15. So there are 15 possibilities. Okay, now the astronaut has some different spacesuits and some different helmets. He can make 18 different outfits. How many of each item might he have? You could either try to use your knowledge. This is a problem-solving question, so it's a bit challenging. You could either try to use your knowledge of the times tables or write out the different combinations. So you know that something times something else will equal 18 because he can make 18 different outfits. Or you can try it out by writing it down. So, for example, if the first number in the number sentence represents the number of spacesuits, the second number can represent the number of helmets. But we can also switch them around and get the same answer because multiplication is commutative. Well done for remembering. So we could start with 1 spacesuit and 18 different helmets. Or he could have 18 helmets and 1 spacesuit, which would both give us a combination of 18. Are there any other numbers you could multiply together to get the number 18? Well, I know that 2 times what gives us 18? 2 times 9 also gives us 18. So he could have 2 spacesuits and 9 helmets. Or we could swap them around because multiplication is commutative. He could have 9 helmets and 2 spacesuits, which would also give us 18 possible outfits. Can you have a go? Can you pause the video and think of another multiplication number sentence that would result in 18 different outfits? Well, I've tried 1 times 18, and that gave me 18. I used my knowledge of the 2 times table. I know 2 times 9 equals 18. Can we multiply a number by 3? Because we've got 1, 2, 3. Is there a number we can multiply by 3 to get 18? Yes, I know my times tables, or I can count in 3s to double check. 3, 6, 9, 12, 15, 18. So 18 is in the 3 times table. 3 times 6 equals 18. Or he could also have 6. So this would represent 3 spacesuits and 6 helmets. Or he could have 6 helmets and 3 spacesuits. So 6 times 3 would also equal 18. Are there any other number sentences that we could write? Well, let's have a look. No, so he could have 1 spacesuit and 18 helmets represented here, or 18 spacesuits and 1 helmet. He could have 3 spacesuits and 6 helmets, which we've written here, or 6 spacesuits and 3 helmets. Or he could have 9 spacesuits and 2 helmets, or 2 spacesuits and 9 helmets. So we've listed all the possible combinations, and we've got 2, 4, 6 different outfits that he could make. Now it's your turn to start with activity 1 and have a go at activity 2 if you want to challenge yourself. If you feel like activity 1 is challenging enough for you and it's really making you think, then that's fine. You could still have a go at doing activity 2. But if you feel like you got on with activity 1 quite easily, please make sure you challenge yourself. Okay, so here's activity 1. Trisha chooses a coloring pencil from the following colors: red, blue, pink, yellow, and green. She then chooses a piece of paper from the following colors: white, purple, and brown. How many different combinations could she make? How many coloring pencils do we have? And how many colored papers do we have? So you would represent this not by listing them, but by using the more efficient way of writing a multiplication number sentence. Second question, Rajan can choose between these meals at school. These are the meals he can choose from: veggie lasagna, meat lasagna, pasta veg, and jacket potato. He can then choose one of these desserts: yogurt, cake, or fruit. How many different combinations could he have? So this is activity 1, and this is activity 2. The cafe sells some different sandwiches and some different drinks. It advertises that altogether there are 24 possible combinations to be made. How many different sandwiches might it sell, and how many different drinks? Similar to this Mastronaut question that we have just done. Okay, I look forward to seeing all of your work on Tapestry, and I look forward to see how you have challenged yourself. Please, if you have struggled with any of these activities, You must write it down on a piece of paper so that you can share with me in tomorrow's live session. Otherwise, I won't be able to help you. Okay, I will see you in the next video. Bye, Mandela Cross.